This is question number 2 on page 135, the homework for tonight. This is section 2.9, weighted averages. And number 2 is similar to example 2 in the textbook. So we did example 2 in the class. It's very similar to this one. We're going to set up a table that looks similar to that one. So the two types of solution that she has, it says Mona has 40 milliliters of a 25% solution. And we want to know how many milliliters of a 60% solution should she add to get or obtain the required 30% solution. So what she wants to have is a 30% solution, but she only has two solutions. One is 25% and one is 60%. So since 30 is in between, she can make a solution that is 30% by mixing the 60% and the 25%. And she just wants to know how much of the 60% she needs to mix with the 40 milliliters of the 25% solution in order to get a 30% solution. So if you set up a table like we did in the example one, she has a 25% solution and she has a 60% solution. But what she really wants is a 30% solution. Okay, so the amounts and the totals are what we're wanting here. Okay, the amount of 25% solution, let's look back in our problem. It says she has 40 milliliters of 25% solution. So we're going to write these in milliliters, and she has 40 milliliters of the 25% solution. But she wants to know how many milliliters of the 60% solution. So we don't know how many milliliters of the 60% solution, and we're going to use a variable. This, I'm going to choose X, but you can pick any letter that you want. I'm going to choose X because I don't know how much of the 60% solution. So I'm going to use a variable. Okay. And I know that the total amount of milliliters will be the 40 plus however much of the 60% I have. So the total amount of milliliters in the 30% solution will be the 40 that I have for the 25%, and then however much I add for the 60%. Over here you have some more totals. So since we're talking about a 25% solution here, we have 0.25, which is 25% as a decimal, and we're going to multiply that by the amount of that solution that I have, which is 40 milliliters. And then same thing here, except I can do the 0.6 for my decimal for 60%, but I don't know how much she has. So I'm just going to write 0.6x, because 0.6 multiplied by x is 0.6x. Okay, and then in my last column, I have a 0.3 solution, and I'm going to multiply that by the total amounts, which is 40 plus x. Okay, so I've finished my table now, and my equation is going to come from my totals column over here on the right. So I know that the amounts for the 25% solution and the amounts for the 60% solution are going to be added together to get my final amounts. So if I set up an equation, I have 0.25 times 40 plus 0.6x. I can put a 0 in front, it doesn't matter. Okay, and that's going to be equal to the 0.3 times 40 plus x. Okay, and now that I have an equation, I can solve my equation like I normally solve equations. I have my two sides of the equation, and if I put 0.25 in the calculator and I multiply it by 40, I'm going to get 10. I can't do anything yet with the 0.6x, but I can distribute, so multiply 0.3 times 40 to get 12, and 0.3 times x to get 0.3x, or 0.3x. It's the same thing. Okay, now I want all of my variables on one side and my constants on the other. 10 and 12 are constants because they have no variable, they have no letter. 0.6x and 0.3x are variables because they both have an x. And we want them to be together on one side and the 12 and the 10 on the other side of the equal sign. So on the other side of this line. Okay, so I'm going to start out by just moving the 0.3x to the other side. Okay, and to move something across the equal sign, I do the opposite. So I want to get rid of it or make it equal 0. So I'm going to take 0.3x and I'm going to subtract 0.3x. And whatever I do on one side, I have to do it on the other side the same way. So because I'm subtracting x's, I subtract it from the x. So I'm left with the 10 I did not change. 0.6x minus 0.3x is 0.3x. And I did not change the 12. This part gave me 0. So I don't need to have that anymore. Okay, so now I have all the variables on the left, but I want the constants on the opposite side. So I'm going to move this 10 so that it's with the 12. It's a positive 10, so to move it across an equal sign, I would subtract it. And over here it's equal to 0 now. I still have 0.3x. And when I subtract 12 and 10, I get 2. Okay, at this step, I'm left with multiplication here. So this is 0.3 multiplied by x. And so I need to do the opposite of the multiplication here to get rid of the 0.3. I don't want that 0.3 there. My goal is to get the x alone. Okay, so since this is multiplication, I'm going to divide to solve because I always do the opposite of the operation. All right, I'm left with x. This is technically a 1x because 0.3 divided by 0.3 equals 1. But 1x is the same as just x. Okay. 2 divided by 0.3 gives me 6.66 forever. Okay, so I look back in my table and I see what I'm talking about here. This is the 60% solution, the amount of 60% solution that I have. So I'm going to take 40 milliliters of 25% solution and I can mix it with 6.66, or let's round it to about 6.67 milliliters of the 60% solution. And if I mix these 6.67 milliliters of 60% solution with the 40 milliliters of 25% solution, I'm going to get my 30% solution.